Okay, so I'm going to be very honest. This is the take 2 of this proof because there was such a delay in the last time because I wasn't seeing where this was going. So this is take 2. So again, what I would do for this proof is pause the video, copy down the given and the proof, statements and reasons, and a nice diagram. Notice in this one that there are 3 pieces of given. So go ahead and pause it, copy that down, and then restart. Okay, so you always start with a piece of given. Again, there's 3 pieces. I personally do not like all 3 pieces shoved into the same statement. So I have C is the midpoint of AE, and that is given. Okay, so this is what we talked about in class. What do I get from that? So if C is the midpoint of AE, then I know that AC is congruent to CE. I'm not that picky on whether or not you have a congruency symbol or an equal symbol here. I'm okay. So number 2 would be the reason why I can say that is because, remember I said that if you see a keyword somewhere in your proof, you're probably going to have that definition of midpoint, or if it said something about bisector up here, you're probably going to have definition of bisect, so look for those keywords. So this would be the definition of midpoint. So I'm going to use the next piece of given. C is the midpoint of BD. Again, that was given. And what do I get from that? So if C is the midpoint of BD, that means that those 2 pieces are congruent. So CD, now I would normally say DC just because of how it's going in my diagram, but I don't want to put DC if I'm asked to prove CD, because that's going to just confuse the crap out of me in the diagram. So I want to make sure that I'm consistent. So CD is congruent to, I would say BC, make sure there's no other BC or CB anywhere, and there's not. So BC, and again, that is the definition of midpoint. And then I know that AE is this whole piece that is congruent to this whole piece. I'm going to use my 3 ticks. So notice that my diagram is getting a little bit hairy here with all the different colors and tick marks. So I have that AE is equal to or congruent to BD. I'm not going to be that picky. And this is also a given. Okay, so all of those 5 steps already, and we are just using the given. Okay, so now we're going to build on that. Well, like I said, 99.9% of the time, if you are dealing with segments, you're probably going to have the segment addition postulate. So the segments I'm looking at are AE. So I know that AC plus CE equals AE. So this piece plus this piece equals the whole piece. So that is the segment addition postulate. And then I have another segment of CD plus BC, because I want to be consistent, equals all of BD, again by the segment addition postulate. Okay, so now I need to figure out where am I going from here. And I'm kind of wondering, why do I have these pieces? How am I going to use that? Well, if I know AC is equal to or congruent to CE, anywhere I see an AC, I can put a CE and vice versa, okay? So I got to figure out which one do I want to substitute. But if I look at this, I am trying to prove AC, so I want to make sure I don't get rid of AC. So AC is not going to change And because they're congruent, I'm also going to be putting an AC in here. So I have AC then plus another AC equals AE. And that would be substitution. And I like to write down what statements I use in my substitution. So I use the idea from 2 and put it into number 6. So 2 and 6. Remember not to use SUB because that would be bad. We have a subtraction property too, so don't use that. So I am also going to use this next piece. Use a different color. Use my red. So I'm going to do the same thing with other segment addition. I know that CD is congruent to BC. So notice in my proof, I want to keep CD. So CD doesn't change. So CD is not going to change. But BC is also same thing as CD equals BD. And I can say that because of substitution again. And I'm putting the idea from 4 into number 7. Okay? So, building on, let's see. So I know then that AE is equal to BD. So AE equals BD. So I can take these two pieces and set them equal to each other. Okay, so there's my AE. There's the fact that it's equal to BD, which is right there. And I can do that again by substitution. And I'm looking at 5. So the idea of 5, and I'm putting in 8 and 9. So I'm using 5, 8, and 9. So this proof is getting really long. Okay, so now I'm looking at it going, okay, I have AC plus AC. So that means I have 2 ACs. This means I have 2 CDs. And this would not be substitution. It's not the addition property. Because I'm just combining these two on the same side, this would be combine like terms. And so now what I notice is that they both have a 2. So if I divide both sides by 2, I get AC to equal CD. So this would be the division property of equality. And this matches my proof. So I'm done. Again, that was a pretty long one. So that has a whole bunch of stuff in there. So from the idea of midpoints, using segment addition postulate, using several substitutions. So this is a proof that has a whole bunch of stuff in it.